For millennia, the night sky raised more questions than answers for humanity. Now, breakthroughs in space science are allowing us to peer into the cosmos and venture to unexplored worlds. New and wondrous views reveal the greatest mysteries of the universe. Epic discoveries, not only in our solar system, but in the far reaches of our galaxy. Cosmic vistas that change everything we know about space and life. Our universe is full of wonders. Countless stars, planets, and galaxies that ignite our imaginations and inspire us to explore. Yet amid the beauty and splendor of space lie dark mysteries that we long to uncover. Among them, none is closer to us than our own moon. This familiar companion that lights up our nights has been keeping a secret, one that for millennia remained hidden from sight.
Even though the moon is far away, we're intimately connected. Its gravitational pull creates our ocean's tides.
We all have a relationship with the moon. Some of us find it beautiful, some of us find it mysterious. But we've only seen one side of the moon, the side that faces us. From Earth, we can't see the far side.
Sorry, Pink Floyd fans, but there is no dark side of the moon. Both sides get the same amount of light and dark. But it's the far side that we never get to see. No matter how big your telescope is, if you're looking from Earth, it's always the same view. Some see a man in the moon. Aztecs, Mayans, and Chinese saw a rabbit. Some Native American cultures see a frog. But whatever you see, it's always on the near side of the moon.
This is because of a phenomenon called tidal locking, which happens when a moon or planet becomes gravitationally synchronized with the body it orbits, keeping the same side always facing it. And because our moon is tidally locked in such close proximity to Earth, it carries a surprising secret.
The moon is not a perfect sphere, and the reason for that is our Earth, which is constantly pulling on it with its own gravitational force. The Earth's gravity pulls the moon unevenly, so it gets turned into this oblong shape that's a little bit longer in one direction. And the part that's longer points straight at us because the Earth is what's pulling it into that shape. As a result of that, as the moon goes around us, it's always the same side that's facing us. Now we want to know what's on that far side.
Humanity's quest to the far side of the moon began in 1959, when the Soviet Union launched their Luna 3 probe to capture the first images. Knowing that sending a spacecraft into uncharted territory was a risky endeavor, the Soviets kept the mission quiet in case it failed.
It didn't fail. And even though the 1959 photos were blurry, they were still the very first photos of the far side and gave scientists a real shock.
There was no mistaking the fact that the far side of the moon looked nothing like the near side.
The landscape on the far side was found to be much more extreme. There were huge mountains, many more craters than on the near side, and almost none of the dark plains that we're used to seeing on the near side. Those dark areas on the near side are called Maria, which is the Latin word for sea, because ancient astronomers thought they might have been bodies of water. 30% of the side of the moon that we see is covered in Maria, while only 1% of the far side is.
The two sides were as different as the Himalayas and the Sahara. And that was confusing. So Earth has different topography because of things like tectonic plates moving the ground, and oxygen and water and lots of living and dying. But what were the forces that were making the moon look like that? That was a mystery.
Hoping to learn more about the mysterious far side of the moon, NASA attempted to land there in 1962 with their Ranger 4 mission. But instead of a soft landing, the spacecraft crashed into the surface and failed to return any data. The rugged terrain isn't the only challenge of landing on the far side. Radio signals from Earth are completely blocked by the moon itself. Because these obstacles appeared insurmountable, scientists turned their focus to the more hospitable near side.
In 1968, Apollo 8 was launched to collect information NASA would need for moon landings, but it also caught a glimpse of the far side. The photos they took revealed craters within craters, and also a much thicker surfaced crust on the far side than on the near side. The differences were really piling up, and the Apollo 8 astronauts were the first to see it with their own eyes.
And the following year, one man would come closer to the far side of the moon than any human in history.
When people talk about the Apollo 11 mission, everybody pays attention to Neil Armstrong and Buzz Aldrin because they got to walk around on the moon and pick up the rocks. But they weren't the only two people who went to the moon. At the same time, all alone, and I mean all alone, no radio contact, no ability to reach anyone anywhere in the universe, astronaut Michael Collins stayed in the command module and orbited the moon, spending 48 minutes above the far side 14 times over.
And we've had loss of signal as Apollo 11 goes behind the moon.
After the Apollo missions, lunar exploration stalled. And that would be the last time we laid eyes on the far side for nearly 50 years. But our curiosity endured. In 2009 and 2012, to pave the way for future landings, NASA's Lunar Reconnaissance Orbiter and GRAIL mission returned to map the moon's far side.
We now had more detailed views of the differences between the two sides of the moon. Have a look. You can see they're different. Not only are there more craters on the far side, but there's another difference. You can see this super crater full of smaller craters. You see that dark area? That's called the South Pole Aitken Basin. And it's called that because it extends all the way from the South Pole to the Aitken crater.
Not only is this the largest crater on the moon, it's the largest basin anyone has found anywhere in our solar system. It's 2,500 kilometers wide.
The basin is thought to have formed when a celestial body collided with the moon during the late heavy bombardment, a tumultuous period, 4.1 to 3.8 billion years ago, marked by intense asteroid and comet impacts across the inner planets, including Earth. But our universe's violent past extends even further back and could play a role in the very formation of our moon.
The theory goes that some giant object smashed into our Earth and that the wreckage and the debris from that collision actually flew off the Earth and formed into our moon.
This theory was later supported by evidence when moon rocks brought back by the Apollo astronauts were found to have similar chemical composition and minerals as Earth rocks.
This is pretty rare. Not big objects hitting each other in space, that happens all the time, but moons being made out of the same source material as the planets. You don't see that with the moons of Jupiter, Saturn, or Neptune.
A collision of this magnitude would have generated immense heat, leaving both Earth and our newly formed moon covered in oceans of lava. But the moon's smaller size means it would have cooled much faster than the larger Earth.
So when Earth got smashed by that Mars-sized object, it probably heated up to about 2,000 degrees Celsius and stayed that way for about 1 million years. So we were heating the near side of the moon, but not the far side.
This is backed up by NASA's Lunar Prospector, which discovered more heat-generating elements on the near side of the moon. And the GRAIL mission found that this extra heat had resulted in a thinner moon crust on the near side.
So it's not that the moon is mysteriously thicker on the far side. Maybe it's just thinner on the side we affected.
This aligns with what we've learned about the moon's Maria. The dark areas on the near side that we know so well aren't oceans as ancient astronomers thought. They are huge eruptions of molten rock caused by Earth's heat.
So, could this be the reason for the moon's dichotomy?
Sure, the Earth heated the side of the moon that's facing us, but is that really all there is to it? Getting literally to the bottom of this means analyzing the geology and the chemistry of what's underneath the lunar surface.
It's called the mantle. You've heard of it. Earth has one too. It's that big area between the core and the crust. A lot of scientists believe that the mantle is where the answers lie to the secrets of the moon's two-faced nature.
But breaking through the moon's thick crust to reach the mantle is no easy feat. That's why the South Pole Aitken Basin, where the massive impact that created the crater and likely churned up chunks of the moon, might be the best place to look. It had been 57 years since humans last attempted to land on the far side. But on January 3rd, 2019, China's National Space Administration was about to embark on a bold new attempt.
The mission was called Chang'e 4, and if successful, would be humanity's very first controlled landing on the far side of the moon.
The Chang'e mission chose what they hoped would be a good landing spot, a flat area in the Von Karman crater, which is inside the huge South Pole Aitken Basin.
With the moon blocking direct radio contact between Earth and the far side, the Chang'e 4 mission includes a relay satellite to bounce the signal from Earth to the spacecraft.
As the lander approaches the moon, it switches to autopilot and cuts contact with the satellite to conserve energy.
So for a few minutes, the most important minutes of the whole mission, they have to trust their technology.
You've got people who have dedicated years of their lives to this mission. Now, all of that work comes down to the next few seconds.
Moments later, the signal comes in.
And it's a total success.
Chang'e 4 sends back its first awe-inspiring photos after its historic landing on the far side of the moon.
Now, the work of further unraveling secrets of the moon's far side can begin. The landing module, Chang'e 4, named after the Chinese moon goddess, deploys its rover, which begins roaming the lunar surface.
The rover packs a lot into its squat frame. It's got a particle analyzer and a spectrometer to examine lunar dust and rocks, and it has radar that can probe more than 100 meters below the surface.
4 months after landing, the China National Space Administration announces that the rover has completed its primary objective, identifying rocks that appear to be mantle material on the far side of the moon. But Chang'e 4 was designed to collect data, not return samples to Earth for analysis. So now, China is preparing for a new mission, one that marks the most challenging phase in their quest to unravel the mysteries of the far side of the moon.
In May of 2024, the China National Space Administration launches Chang'e 6. It carries a lunar lander and a rover, but also an ascender module to carry collected material back to the orbiter and the return vehicle. As a planetary scientist, the idea that we were going to go and retrieve a sample is absolutely incredible because we don't often get to bring things back from the places that we visit with these robotic spacecraft. And to be able to take these samples and analyze them in a lab, that really gives us information that we can't get otherwise.
Just 2 days after landing, Chang'e 6 collects nearly 2 kilos of moon rocks and soil.
They also leave something behind. Their scoop etches a mark on the surface of the far side of the moon. It's a Chinese character, the first one in the word that means China.
The material Chang'e 6 collected is successfully transferred to the atmospheric re-entry module and sent back to Earth.
It's landed. You can hear applause from the ground controlling command center.
China is the first nation to return material to Earth from the far side of the moon.
Seeing the footage was incredible because you're not guaranteed that the collection is going to work. There's so many single points of failure that you can have getting there, getting the sample, getting that sample back to Earth for scientists to be able to analyze it. And so the fact that all of these things worked extremely well is absolutely amazing and a testament to the ability of the engineers that make these spacecraft for us.
As of 2025, scientists are still studying the data from the Chang'e far side missions. But so far, one discovery stands out: water. The far side samples contain significantly less water than those from the near side, suggesting a deep internal divide in the moon's water distribution. Some scientists believe this could result from the massive impact that created the South Pole Aitken Basin, which altered the moon's interior by pushing heat and water molecules towards the near side. But the mystery of the moon's far side doesn't end there. China, along with other spacefaring nations, are planning on future missions to hopefully uncover the secrets of the moon's two sides.
There might be many reasons why the two sides of the moon are different from each other. We thought landing on the far side would end the mystery, but it could just be the beginning.
While the far side is gradually revealing its secrets, the moon still holds mysteries we long to uncover. But the story of our closest celestial neighbor is a calm one compared to the chaos in the cosmos raging all around it. A boundless expanse of shifting celestial bodies and turbulent forces. Staring up at the stars on a quiet moonless night, space appears vast and serene. Its calmness hinting at an underlying order that we had come to understand. Stars were born from orderly spinning disks of gas and dust. Planets fell in line around their suns. And black holes anchored themselves at the center of galaxies. The cosmos, it seemed, followed the rules.
Stability makes us feel safe. And nothing feels less safe than finding out that the rules that we took for granted don't apply.
Sure, planets and moons usually stay in their orbits. Usually.
But over the past few decades, a band of cosmic outliers has emerged. Stars that tear through space at breakneck speeds. Planets that wander alone with no home star. And black holes that drift aimlessly through the void. These dark mysteries are defying the very rules we once thought were unbreakable. On December 19th, 2013, the European Space Agency is about to launch the Gaia spacecraft.
The aim of the Gaia mission was to collect the origin, size, distance, and other properties of a tremendous number of objects in space, and to collate this into the very finest 3D map of space ever made.
Analyzing all these space objects will reveal erratic ones that don't play by the rules.
And because these rule breakers bear the scars of past collisions, merges, and gravitational disruptions, they can offer vital clues about the inner workings of our universe. The Gaia team is glued to their screens as the rocket prepares for launch.
launch is a success, but the team still has to wait for the next crucial phase, Gaia's separation from the launcher.
At ESOC and elsewhere, today represents years of work. Here's the good news. Soyuz has successfully separated her passenger Gaia.
The relief, the joy, you can just imagine the high fives around the room as everyone realizes we've made it.
The spacecraft has now begun mapping the Milky Way from its stable orbit, where it will survey approximately 1% of the hundreds of billions of stars in our galaxy, helping us uncover the secrets of some of the rogues wreaking havoc in the cosmos. Among them, one is taking speed to a whole new level. In 2005, astronomer Warren Brown and his team at the Harvard-Smithsonian Center for Astrophysics were tracking stellar streams at the edge of the Milky Way when they discovered a hypervelocity star racing through space at an astounding 2.42 million kilometers per hour. Fast enough to travel from Earth to the Moon in just 9 minutes.
Most stars in our galaxy go around 700,000 kilometers an hour, so hypervelocity stars earn their name by going a lot faster.
And these aren't shooting stars. That's the incorrect name that we give to meteors. These are actual stars, massive stars.
This 2005 sighting was the first time a hypervelocity star had ever been observed.
The good news is that this cosmic zoomer wasn't going to hit us. In fact, it was heading out of our galaxy.
A star traveling at such an astronomical speed that it can escape the gravitational force of the Milky Way, which can hold on to billions of stars, not to mention everything else you see up there, is truly a cosmic rogue.
Since Brown's groundbreaking discovery, astronomers have observed over 1,000 hypervelocity stars. But what kind of cosmic forces hidden in the darkness could be powerful enough to send a star hurtling through space at such extraordinary speeds? As the Gaia spacecraft continues to make its way through the breathtaking vistas of our galaxy, it begins to reveal ways in which hypervelocity stars achieve their extreme speeds. One explanation points to satellite galaxies, small companion galaxies that orbit much larger ones under the pull of their gravity.
Orbiting our galaxy, we might have nearly 60 satellite galaxies. Their smaller size can leave them vulnerable to being torn apart by our powerful force, which can send some of their stars hurtling away, resulting in hypervelocity stars.
And it's not just solo stars at risk of being flung across the galaxy at extreme speeds. Pairs of stars that are gravitationally bound to one another in binary systems are at the mercy of their partner's fate.
Out in the galaxy, massive stars live fast and die young. When they exhaust their fuel supply, they can explode in a cataclysmic supernova. If there's a bound star next to it, when that shockwave happens, it can hurl it out of the galaxy.
And when two gravitationally linked stars get close to a black hole, its intense gravity can grab one of them while the other gets flung off into space at an alarming rate.
So black holes are force multipliers for hypervelocity stars. And there's a black hole in the center of most galaxies, including ours.
Thanks to the Gaia mission and its extensive catalog of objects' movement in space, we can see these hypervelocity stars spread throughout the Milky Way galaxy. Most of them speeding away from the supermassive black hole at the center of our galaxy.
But what happens to that unlucky star when it drifts too close to a black hole?
One of the great mysteries of black holes is we don't know what happens to the material once it goes inside. Because black holes are very small and very dense. It could go denser and denser and denser, maybe even reaching infinite densities. So this is the playground for theorists. They have so much fun imagining what might happen to that mass. Is infinite density possible? Could we build a wormhole or something exotic inside of a black hole? We can't validate those theories with observations because we can't see in there. But it's exciting and fun to think about all of the different possibilities.
While most black holes remain anchored in place by the gravity of the surrounding celestial bodies, every so often, one breaks free and becomes a rogue black hole, silently roaming the depths of space all alone. But spotting these dark wanderers isn't easy.
It's not exactly that black holes are black in color. It's that no light can come out, and so it's very difficult for us to see them. We're only able to locate some of these black holes because of the influence that they have on other objects that are nearby them.
In 2022, the very first discovery of a rogue black hole was in our galaxy. Tracking the activity around it, NASA's Hubble Space Telescope estimated its speed to be about 162,000 kilometers an hour and its mass to be over 7 times that of our sun.
So how did this black hole go rogue? Scientists believe it was likely kicked out of its home when the star it came from exploded unevenly, launching it into deep space. And it may not be the only one.
There could be millions of rogue black holes in our galaxy. And cutting-edge astronomy is always learning more about these cosmic rule breakers.
High in the Andes Mountains of Chile sits the Vera C. Rubin Observatory. Commissioned in 2025 and named for pioneering astronomer Vera Rubin, it now sets its sights on unraveling the mysteries of cosmic rogues.
While the Gaia mission built the most accurate 3D space map in history, the Vera C. Rubin Observatory will put it in motion, creating an ultra-high definition time-lapse movie of the world above us. And researchers will be able to access it from around the world without being on site.
By capturing the subtle movements and light distortions caused by celestial bodies, the Rubin Observatory will help scientists better understand the hidden mechanisms of some of the universe's most elusive and unpredictable travelers, including one of the most haunting mysteries of all, rogue planets. For centuries, scientists believed that all planets were gravitationally bound to a parent star. But in 2012, astronomers discovered the first rogue planet, drifting alone through the cosmos.
This one is 100 light years from us, and no star can be seen anywhere near it as it wanders alone. We on Earth are stuck in orbit around our star, but not this guy.
And it's not the only rogue planet. In fact, there could be trillions of them.
So, how do these lone wanderers come to be?
Some astronomers believe these rogue planets were formed at the beginning of the universe when the Big Bang made things pretty chaotic.
The turbulent and unstable conditions of the early cosmos would have made it easy for small planet-like objects to be knocked around, flung into space, or prevented from ever settling into orbit around a star.
Like hypervelocity stars, some rogue planets may have been blasted out of their orbit by being too close to the explosion of a supernova.
And even today, sometimes crowded star clusters are to blame.
There's a fair number of fights up there, and always over gravity. A small planet gets too close to a big one, and the one with the more intense gravity force shoves the littler one out through the swinging doors. Or two stars get into a gravity tussle, and any planet unlucky enough to get too close gets tossed out into the street.
Learning more about the mysterious rogue planets can help us better understand how planets form, evolve, and survive outside the safety of a star's orbit. In 2025, the European Space Agency's Gaia mission completed its vast survey of the cosmos. After more than a decade of groundbreaking observations, Gaia recorded more than 3 trillion measurements of over 2 billion stars and celestial objects. Now, scientists are working to transform that data into the most detailed 3-dimensional map of the Milky Way ever created, revealing our galaxy like never before. As these newly discovered rogue worlds continue to shake up the cosmos, one thing is certain: the universe is full of mysteries, and one of them lies in a world much closer to home. Named after the Roman goddess of love, Venus's dazzling beauty has captivated us for millennia. Shining brighter than any other planet in the night sky, it has long been a symbol of wonder and inspiration. And the more we learned about her, the more we began to realize just how similar this mysterious world is to our own.
Both planets are about the same size, we're about the same weight, we're about the same age. And below the surface, Earth and Venus are believed to have been formed from the same materials. If you cut us in half, we both have an iron core, we both have a mantle of magma, and we both have a solid crust. But it's spooky how different Venus and Earth are, considering how much we have in common. We're like twins, but in a horror movie where one of them just goes horribly wrong.
For centuries, astronomers peered at Venus through telescopes, wondering what its thick reflective clouds were hiding. Many believed that, like Earth, those clouds held water. And where there was water, there could be life. Some imagined lush jungles, vast oceans, and even alien civilizations thriving under the haze, sparking decades of fascination and debate. But the dark secret Venus was concealing beneath the veil was one that wouldn't be revealed until the Cold War era.
We've all heard a lot about the US-Soviet race to the moon, but the Cold War superpowers also had a race to Venus.
Being the first to reach the planet and uncover its mysteries became another prize in the rivalry.
It kicked off in 1962 with NASA's Mariner 2.
The Mariner spacecraft, now on its way to Venus, is the most intricate instrument in the history of space science.
The spacecraft successfully completed a flyby of Venus, revealing a world far more extreme than we ever imagined.
Mariner 2 showed that Venus has the hottest temperature of any planet in our solar system. It averages 500 degrees Celsius, which is twice the temperature that we cook food at in our ovens.
Discovering Venus's extreme heat only deepened our curiosity. And in 1965, the Soviets launched Venera 3 to pierce through the clouds and finally reveal its surface.
It made history as the first spacecraft to ever reach the surface of another planet. But it wasn't a perfect success because Venera 3 crash-landed on Venus and it returned 0 information back to Earth. But that didn't stop the Soviets from pressing on, extending their lead with subsequent Venera missions.
The Venera spacecrafts were designed with heat-resistant systems, allowing them to land on Venus's scorching hot surface.
But every spacecraft that managed to land on Venus was quickly destroyed by heat and atmospheric pressure that is over 90 times that on Earth.
But in 1976, the Venera 9 managed to survive for 53 minutes before losing contact. And in that brief time, it captured the very first images of Venus's surface. The images revealed nightmarish vistas, a bleak, jagged expanse of rocks broken over millennia beneath a crushing atmosphere. Then, NASA's Pioneer Venus mission revealed another layer of hostility. Venus's clouds are composed almost entirely of concentrated sulfuric acid droplets, one of the most corrosive substances known.
Sulfuric acid droplets result in acid rain and lightning flashes. Plus, the planet's punishing heat means that any falling liquid evaporates before it hits the surface. So the surface is dry and filled with toxic gas. Sorry, life.
Although these findings suggested that Venus's current conditions aren't suitable for life, another clue from the Pioneer missions hints at a much different past. Higher than usual amounts of a type of hydrogen known as deuterium was detected in the atmosphere. This could suggest that the planet once had oceans and a milder climate, much like our own.
Some scientists believe that our scorching hot neighbor Venus might have had the very first ocean in our solar system.
But if Venus was once more Earth-like, what catastrophic forces transformed it into the hellish world it is today? Eager to understand our twin planet, the missions continued. And in 1982, Venera 13 sent back the first colored images of Venus, revealing its cracked surface and yellow, hazy sky.
Venera 13 gave us even more information. The probe's exterior was equipped with a microphone, and for the first time, humans could hear what another planet sounded like.
Like, how amazing is that? That's so cool. To think that's an entirely different world.
Space sounds are neat because not only are you hearing whatever makes the sounds, but the nature of the sound is changed by the atmosphere. Kind of like how everything sounds different underwater because you're underwater. Everything sounds different on Venus because you're on Venus. The atmosphere has different chemicals in it. They transmit sound differently. In a way, you're kind of hearing what hell sounds like. It's the closest thing to hell in the solar system.
I love that you can not only hear the sound of wind on an alien planet, but you can also hear sounds from our machines, our equipment that we sent to another planet. Both of those things to me are amazing. And the fact that it's Venus, where being on the surface would absolutely kill any human in seconds or even faster, is even more amazing yet.
Missions to Venus continued, but in 1989 we saw a turning point.
It was the beginning of the end of the Soviet Union, and their funding for space exploration dried up. But the United States continued their relentless pursuit for answers. That same year, NASA's Magellan mission mapped the surface of Venus using high-resolution radar. The spacecraft discovered that 98% of the surface was covered with volcanoes and lava flow, evidence of a massive heat event geologically dated to around 500 million years ago.
Could the catastrophic event that resurfaced Venus also have buried life underneath? Because an eerily similar thing happened right here on Earth.
Over 200 million years ago in Russia's Siberia region, volcanic eruptions and lava flow led to the biggest extinction of life on Earth.
You can see it looks fine there now, but at the time, nearly all living things were eliminated in a sequence of events that lasted millions of years.
Volcanic eruptions spread chemicals such as chlorine, which can thin the ozone layer, resulting in danger from UV rays. They also release greenhouse gases like carbon dioxide, which cause global warming and decrease oxygen in the oceans, starving marine life.
Sound familiar? It's climate change, whether in ancient Russia or on Venus. Scientists now believe that this gigantic volcanic eruption discovered by the Magellan mission kicked off a climate catastrophe that warmed our sister planet and evaporated all of Venus's water.
As Earth's temperatures continue to climb, we can't help but wonder if our twin planet stands as a warning of what lies ahead for us. Many scientists now believe that understanding Venus's past could hold the key to protecting our future.
Once we learned about the volcanic climate change on Venus, it broadened the participation. Instead of only 2 countries, Now more countries wanted to get involved. And that brings us to Japan.
In 2010, Japan's Aerospace Exploration Agency, JAXA, launches the space probe Akatsuki on a 7-month journey to Venus. The mission's primary objective is to study how the planet's surface and atmosphere interact, which is a crucial step towards understanding Venus's drastic climate shift.
At 1.5 meters high and wide, the Akatsuki probe is packed with detectors to help us measure the atmosphere. Its ultraviolet imager and long-wave infrared camera allowed us to detect thermal emission and track cloud motion.
In December, mission control staff watch and wait as Akatsuki approaches orbit.
Spacecraft need to execute precise maneuvers at the right time to enter into planetary orbit.
But something goes wrong. Akatsuki misses its chance and is unable to enter orbit with Venus. The spacecraft then veers off and begins orbiting the sun.
It's like when you and I are on an airplane circling the airport, unable to land, except this is much longer. The spacecraft orbited the sun for 5 years.
That is the challenge of all of these incredibly complicated space missions. They do not always, in every step, go according to plan. But you don't have time to be upset. You don't have time to react emotionally. You have to react logically and say, okay, if not this, then what? So the engineers, the scientists, they're all ready with that mindset of what do we do next? The JAXA team, after exploring every inch of the probe, discovered that it was a faulty engine valve that caused the engine to shut down prematurely during the insertion into Venus's orbit.
Once the mystery was solved, JAXA was able to use alternate thrusters on board Akatsuki. And the probe was finally able to enter Venus's orbit.
Once confirmation that we're in orbit after all, then you can let your emotions out.
I cannot imagine the relief they must have felt. The whole time that probe was orbiting the sun, they must have been wondering, will we ever be able to solve this problem, or are we spending more time on a mission that's bound to fail?
The spacecraft quickly made up for lost time, discovering something extraordinary. A massive wave in the clouds that stretched almost across the entire planet.
Cloud waves are formed by wind meeting a mountain and the air being forced up. What Akatsuki finds is a 10,000 kilometer long cloud wave. How big are these mountains on Venus?
Adding to the mystery, the enormous cloud wave doesn't move with the rest of Venus's atmosphere, as clouds do on Earth, hinting that it may be anchored by something on the planet's surface. This tells us that Venus's surface and atmosphere are still connected, despite the crushing pressure and extreme heat. Now, scientists are eager to build on Akatsuki's findings to learn more about what extreme forces are holding the massive wave in place.
All over Earth, additional missions to Venus are being planned, from NASA to the European Space Agency to the Indian Space Research Organization.
And Russia's getting back in the race with a new Venera probe in the works set to head for Venus.
By continuing to unravel the mysteries of our twin planet, we hope to gain deeper insights into climate change and planetary evolution. Insights that might help us save our own planet from a similar fate. From the moon's hidden vistas to rogue worlds cast adrift in the cosmos, and a planet transformed into a scorching inferno. Every discovery reminds us that our universe is an endless expanse of dark mysteries, and our journey to uncover them has only just begun.